Okay, unbalanced forces. So to get motion or a change in direction, that you have to apply a force, and that force obviously can't be balanced, or else you're not going to go anywhere. So let me get you to think about this in a few different ways. So all my forces are going to come in pairs, but what we really care about are forces that are acting on a particular object. So in this case, we're looking at a box, and the force is acting on that box in the vertical dimension. Not interesting, right? It's an equilibrium in vertical direction, so it's not accelerating or changing directions. And in the horizontal direction, I have a force pulling forward that's larger than the frictional force pulling backwards. So this is an unbalanced force, and we'll be able to figure out what the acceleration of this box is, for instance, if we knew the forces and the mass. So we can make it a little bit more complex. That's what we like to do. So this is an example of a conical pendulum. So this is a pendulum that's going around in a circle. And notice that there are only two forces, right? So we have an object, we call it the bob, and the bob is being pulled down by gravity and is being held by the rope. So the only contact it has is the tension that exists. And if we break these forces into components, so if we break the rope at different angles, you can see that that vertical component again cancels. So it's an equilibrium vertically. But that horizontal component is acting to apply a force onto that object. Now, this force is not accelerating the object in terms of its speed, but it is accelerating it in terms of changing its direction. So we're going to be really careful that forces can do two things. Forces can change the speed of an object, or it can change the direction of an object. So notice an object that experiences a change in direction is experiencing acceleration. Kind of weird to think about, right? So I'm not changing the magnitude of velocity, but I am changing the direction of velocity, and that takes acceleration. We'll get into things that have more than one box. So this is another two-box system. So we think of a pulley as something that just changes the direction of the force. Right now, they're massless and frictionless, so there's no change in the tension. So the tension will go right up the wire from the red box to the blue box. And again, what we want to do is we want to think about the forces that are involved. So we can look at force diagrams, which are handy ways to think about these things. And notice what I have, though. I have two different dimensions. So I have the dimension that goes up the slope, which I'm interested in, and the dimension that goes vertically for the red box that I'm interested in. So what I want to do is I want to think about the direction of motion. So I'm going to make one line, essentially. I'm going to say, well, the direction of motion, I'll guess. I don't need to know. I can guess. Well, I can say, well, maybe it's going to go down. The red one's going to fall and drag the blue one up the box, up the ramp. If you guess wrong and it turns out that is actually moving the opposite direction, you'll still get an answer. You'll just get negative values for things. So you get a negative acceleration. So if you predict it going in one direction and you decide that's the direction I'm going to call positive, that's fine. And if you calculate a negative number, you know your prediction was wrong. It was actually going the other way. So notice on this that for the blue box, I'm going to end up when I separate components. Does it show this? No. So if I separate the components of gravity into that which is orthogonal or perpendicular to the ramp, and that which is going directly down the ramp, then I'll end up having sort of static or no net force acting in the vertical dimension for the ramp, but I will have a net force acting in the horizontal dimension for the ramp. And similarly for the red box, for it to actually accelerate, for it to move, that force of gravity must be greater than the force of tension. Right? So it's not static, so it's not stationary. I will have a net force that's acting on that, and that force will act to accelerate that block and the system. Anyway, useful to think about these things. So the force diagrams are really helpful ways to think through, free body diagrams, helpful ways to think through these sorts of questions. And remember, force is going to do two things. So if I have a non-static force, so if I have an unbalanced force, I can either increase the speed, change the speed, increase or decrease it, or I can change the direction. So really important. We'll get to that in a little bit. If this is helpful, bye.